All right, our last L'Hopital's rule problem. So let's plug in pi over 2 and let's see what happens. So the sine pi over 2 raised to the tangent of pi over 2. The sine of pi over 2, so that's up at the top of our unit circle. Sorry, a dog. Is, 1 second please. Okay. Sine of pi over 2 is 1, and the tangent of pi over 2 is 1 divided by 0, which means it's undefined. There's a vertical asymptote there that's going to infinity. So 1 to infinity is a indeterminate form, meaning we can use L'Hopital's rule. So let's get started. All right. I need this to be a ratio, which means I need to bring that tangent x down from the exponent. So I'm going to use a natural log to do that. So if this is my current function, if I take the natural log of both sides, I can then use the log power rule, not to be confused with the derivative power rule, to bring the power down. So I've got tangent x, natural log sine x. And you might be saying, well, that's not a ratio. Well, it will be once I rewrite this as, once I rewrite tangent as sine over cosine. So sine x ln sine x over cosine, sine over cosine. All right, so this is going to be the function that we're going to work with L'Hopital's rule, but we do need to remember to go back and unnatural log it at the end by raising it to a base of e. All right, so let's go ahead and L'Hopital rule this thing. All right, the derivative of the top, we're going to need, we got to use product rule and chain rule. All right, the sine is going to be first, natural log is going to be second. So the first times the derivative of the second plus the second times the derivative of the first. Alright, so that's just the numerator. The derivative of the denominator, derivative of cosine, is negative sine. Alright, we got some cleaning up to do. I see that sine x times 1 over sine x, that's just going to give me 1. So I've got 1 times cosine, which is just cosine. So looks like this might clean up for us quite nicely. Alright, so we've got top, we've got a cosine x left, plus a natural log sine x. Excuse me. Oh no, what happened? Alright, well, let me just rewrite it. I know it was a cosine x plus a natural log sine x cosine x all over, that was a negative sine x, wasn't it? Alrighty. I see that we could factor out a cosine up top because they do have a cosine in common. So let's go ahead and do that. All right, can I plug in pi over 2 yet? Let's see what would happen. Let's see. In the denominator, the sine, excuse me, of pi over 2, that's the y coordinate. It's 1, so that would be -1 on the bottom. Ooh, that's looking good. The cosine of pi over 2 is 0. Looks like we're going to get a 0 on top. So yeah, let's see. I think we can go ahead and plug it in. Limit as x approaches pi over 2 of this thing is going to be cosine pi over 2 times 1 plus the natural log of sine pi over 2. Alright, this is really messy. All over negative sine pi over 2. Gotta get me an Apple Pencil. Alright. Let's evaluate that. And don't forget, we have to go back and raise it to a base of e since we took the natural log at the beginning. We need to undo that. Alright, cosine of pi over 2. Excuse me. Cosine of pi over 2 is 0, and so 0 times anything is 0. So this whole thing is going to be 0. Over negative sine pi over 2 is 1, so we're getting -1. And 0 divided by anything is 0. Alright, but that is the limit of the natural log of f of x. Right? So we need to raise that to a base of e. And e to the 0 is 1. So the final answer is 1. Please excuse the way I wrote this. Please write your final answer as the limit as x approaches